If you and another object are in space, there is no way to tell which object is moving or not. Click Next to simulate movement. Which object do you think moved? Choose one option. You are wrong. You moved. The box was stationary while you moved away from it at a uniform speed. To be honest, that was a trick question, because either answer can be correct and there's no way to know for sure. This is a good example of relativity. A lot of things like motion, speed, distance are relative. Relative to the box, you are moving. Relative to you, the box seems to be moving. This brings us to our main topic, time. Time doesn't flow at the same pace for everything in the universe, and I'm going to show you how. Click Next Chapter to move on to the next chapter, or click Restart to restart this one. Let's talk about how time is experienced by different entities under different conditions. It has been proven that time moves faster for objects in motion than those that are stationary. I am about to show you a version of the affiliating experiment that proves this. Click Next to see the experiment. Look at the ground in front of you. You'll see an atomic clock. Click Next when you've seen it. Now, look around you. You should see an aircraft. Click Next when you've seen it. Now we'll make the clock start counting seconds. Click Next to do that. As you can see and feel, everything happens as expected. Time is flowing normally. Now we are going to the aircraft, which at the moment is moving really fast. Let's start counting seconds again. Click Next to do that. As you can see and feel, everything happens as expected. Time is flowing normally. This is where things start to get interesting. Click Next to switch to God view. Take a look at both clocks. As we can see, the one on the ground is moving faster. This is actually what happens in real life. Objects moving faster at higher speed experience slower time flow, while stationary objects or objects moving at slower speed experience faster time flow. However, people on the ground and people on the plane do not feel this stretching or compression of time. It doesn't feel different at all. The difference in the flow of time can only be observed when you are comparing between two entities under different conditions. This is known as time dilation. It is the difference in time elapsed measured by two observers due to a speed difference relative to each other. Click Next Chapter to move on to the next chapter, or click Restart to restart this one. Time dilation can actually occur in another form. Look at the ground in front of you. You will see a clock. Click Next when you've seen it. Look around you. There should be a mountain somewhere there. Click Next when you've seen it. Now, we'll make the clock here start counting seconds. Click Next to do that. As you can see and feel, everything happens as expected. Time is flowing normally. Now, we are going to the top of the mountain, which is really high up. Click Next to simulate movement. As you can see and feel, everything happens as expected. Time is flowing normally. Again, this is where things start to get interesting. Click Next to switch to God view. Take a look at both clocks. As we can see, the one at the top of the mountain is moving faster. This actually happens in real life. A clock at the top of Mount Everest will be 39 hours ahead of that on the ground. Objects closer to a gravitational field experience a slow flow of time relative to those farther away. If gravitational time dilation was not discovered, we would be unable to create accurate GPS devices. Because satellites in space are experiencing a slower flow of time relative to us down here on Earth. Click Next Chapter to move on to the next chapter, or click Restart to restart this one. Now, let's move from real, actual proven occurrences to something more fun. As we know from the previous chapters, objects moving faster than others experience a slower flow of time. Now, imagine what would happen if we could somehow invent a way to move at 99% of the speed of light without dying. If we moved at 99% of the speed of light for 10 years straight and came back to Earth, we will find that everybody on Earth would have aged by approximately 71 years. That should count as some form of time travel, right? There's a mathematical equation that can help calculate how much time passes for observers moving at any velocity. It is called the Lorentz equation. You can find it written right in front of you. We have now reached the end of this experience. Click Restart to restart this chapter, or Restart Experience to start all over.